Good morning. Welcome to
FamilyMath number 139.
FamilyMath number 139, powers, logic, and prime numbers. So we did yesterday a really interesting talk about Graham's number, and that had some really interesting and super large powers in it, right?
Yeah.
And so it got me thinking overnight about another really interesting math theorem that has powers in it, and I thought we'd just spend a few minutes talking about it, and it's called Fermat's Little Theorem. Have you ever heard of Fermat before?
Yeah.
When?
And Fermat's last theorem.
Fermat's last theorem. Do you remember what that says?
No.
No? Okay. Well, we're going to talk about Fermat's last theorem at the end. We'll talk about it last.
Yeah.
Okay, so Fermat's little theorem says if P is prime, then x to the p minus 1 power has a remainder of 1 when divided by p for all integers 1 less than or equal to x less than or equal to p minus 1. Okay?
Yep.
So let me show you what that means. Unfortunately, I'm going to have to erase it, but do you understand what this says?
Mm-hmm. Yep.
Okay, so let's look at 5 as an example. Right?
Sure.
So 5 is prime, right?
Yeah. Yep.
1 to the 4th, remember it's p minus 1?
Yep.
Equals what?
1 to the 4th is 1.
1. And what's the remainder when 1 is divided by 5?
1 is divided by 5 and the remainder is 1.
1. Very good. So that works, right?
Yeah.
Okay. 2 to the 4th. Go ahead.
That means this is 16.
Okay, 2 to the 4th is 16. What's the remainder when 16 is divided by 1?
You mean 5?
By 5, sorry, yeah.
1.
1. Okay, so that works. That works. 3 to the 4th, okay. Do you know?
It's 81 divided by 5.
81. What's 81? What's the remainder when 81 is divided by 5?
1.
1. And finally, 4 to the 4th is the last one we need to check. Do you know what 4 to the 4th is?
It's 256.
256. And what's the remainder when 256 is divided by 5?
1.
Okay, there you go. So there's an interesting example.
What?
So it says if the number is prime, then when you raise it to the power 1 less than the number, you always get a remainder of 1 when you divide by that number.
Cool. What about if numbers are not prime when you did this?
Ah, okay. So that's why I want to talk about logic. If a number fails this test,
It's not prime.
it's not prime. Why not?
Because if it passes the test, it's prime because it has a remainder of 1.
Right, if it passes the test, it's prime. If it fails the test, it's not. Sorry, primes pass the test. That's what I mean to say. Prime numbers pass this test. So if it doesn't pass the test,
Then
it's not prime. But if it does pass the test, does that mean it's necessarily prime?
Yeah. Well, not necessarily.
Not necessarily. Not necessarily. Primes pass the test, but maybe other numbers pass the test too. So we're going to talk about that in a little bit as well. But first, let's do an example of a number that's not prime. So give me a small number that you know is
4.
not prime. 4. Okay, great. 4. Let's make sure not primes do not pass the test. 4 is not prime. And let's just see. 1 to the 4th is 1 cubed, sorry.
1 is 1.
Is 1. Okay, so that seems to pass.
Yeah.
2 cubed is
8.
8.
That doesn't pass.
Ah, the remainder when 8 is divided by 4 is
2. No, wait. 0.
0. Right.
0.
Ah, so we can tell that 4 is not prime.
Not prime.
Okay. And I'm going to do 2 more examples in the next video, okay? Some larger ones.
Sure.